Often in statistics we're asked to find the value of a piece of data at a certain position. For instance, the middle value if we're asked to find the median. However, if we're asked to do this with data that's grouped, and very frequently is, then we'll need to use interpolation. So if ever you come across group data, or indeed continuous data, you're going to need to use this technique. Now the first thing that I'd always do with a frequency table like this that's been grouped is to add an extra column with cumulative frequency, because that's going to be useful for working with the data later on. Now the first thing we need to do is find the position of the piece of data that we're interested in. So if it was the median, we know we need to find the middle value, but what actual position is that? Well, we can see here that actually we've got 20 pieces of data, so the middle position will be the 10th piece of data. And if it had been the first quartile or the third quartile we were looking for, then the position would have been different, of course. But we're looking for the 10th position. Now, the next thing we need to do, having decided that it's the 10th piece of data that we need, is to find out which group that resides in. And you need to understand exactly what's going on with this grouped frequency table. Well, I can see the first group contains pieces of data from 0 to 5. The second group contains pieces of data from the 5th to the 15th. And lastly, the last group from the 15th to the 20th piece of data. So from that I know that my 10th piece of data resides in this middle group. So the next thing I'm going to do is draw a representation of that group. You'll always draw a representation of a group that you're interested in, that the piece of data lives in, and in this case it's this middle group. So it'll look like this, and we can see here we've got our class boundaries here. So the middle group, we can see the least value it will take is 1.3 kilograms and the most is 1.4. And I've also put in here the positions of the data that reside in it, so from the 5th to the 15th. But it's the 10th position that we need to find, and it's grouped data, so we're going to use interpolation. And so I'm going to represent roughly where our data is going to be positioned. So our 10th position is going to be there, and I'll draw in that it's our 10th value here. And I know that this value is somewhere between 1.3 and 1.4 kilograms, but I don't know exactly what it is, or at least I'll pretend I don't. So I'll call it M. Now we're going to use interpolation to find exactly what the value of M is, and I'm just going to show you, really what we're exploiting here when we use interpolation. It relies on the fact that we know the 10th value is this interval compared to this interval. And we know in exactly the same way that M is this distance along compared to this overall distance. And so we set up two equivalent fractions. We know that to get to the 10th position we've moved this distance compared to a total of this distance, and exactly the same way on the other side we've moved this distance compared to an overall distance here. And these are equivalent fractions, so we've moved A out of a total distance of B to get to here, and we want exactly the same interval on the top, so we know in exactly the same way we move C out of a total interval of D. And then we can simply put in our values into these equivalent fractions and solve. So we know that A, we calculate this interval here, and we can say that is 10 minus 5, to give us that overall interval of 5, and b, which goes underneath, we calculate this interval here, so this would be 15 minus 5. We work out c. Now we've got an unknown here, but we work out in just the same way. This interval here would be m minus 1.3, and d, this larger interval, would be 1.4 minus 1.3. And of course we can simplify this a little bit. We can see that now this interval is 5 compared to 10. And you could probably see that this was going to be an overall interval of 0.1. And then you shouldn't have any problem solving an equation like this, but we're going to multiply both sides by 0.1, so we would end up with, if I was to simplify the 5 over 10 as a half multiplied by 0.1, and that would equal m minus 1.3. And you can probably see that half times 0.1 would be 0.05, and if I added 1.3 to both sides, I would end up with m equal to 1.35. You may very well have seen this, of course, but this is just to demonstrate the method.